Hi, and welcome to Delview Management's Construction Basics blog, Episode 2. In this segment, we're going to cover the most common types of floor systems used in residential and light commercial construction.
If you watched our last segment, we covered foundation systems. In that segment, we also covered slab-on-grade foundations. This type of floor system is commonly used for the basement and ground floor levels on residential and light commercial construction. There are many other types of floor systems where concrete and steel can be used, such as concrete plank systems, poured concrete on metal decking, and steel reinforced concrete systems. But these systems are not commonly used in residential construction and therefore will not be covered in this session. In this session, we will primarily be concentrating on wood-framed floor systems. Wood-framed floor systems are the most common types of floor systems used in homes and light residential and multifamily construction. This system is commonly used on structures above crawl spaces and basements, as well as upper stories above either wood-framed or concrete walls. Basic wood-framed floor systems consist of several components. These components include, but are not limited to, joists, beams or girders, rim, hangers, blocking, bridging, and subfloor. Typically, wood-framed floor systems on the first level of a structure above a basement or a crawl space are placed directly on top of pressure-treated sill plates, which are fastened to the concrete block or poured concrete walls of the foundation. There is typically a gasket between the sill plate and the foundation called sill seal. These pressure-treated sill plates are typically held down to the foundation with anchor bolts, hold-downs, straps, or a combination of all of these. Typically, the floor joists are placed directly on top of the sill plates with a rim board that is the same depth as the floor joist and runs the entire perimeter of the structure. In areas where termite infestation is a problem, an additional layer of flashing may be used under the sill seal. In some cases where loads from above are a concern, or where the grade is higher than ideal, the floor system may be placed below the top of the foundation on stem walls. This system places the loads from above directly on the foundation walls and makes moisture damage or insect infestation less likely. Joists. On smaller homes, such as townhomes, where the entire width of the structure is within the span of a single joist, the joist will typically run from one side of the foundation to the other and bear on the two foundation walls that are running perpendicular to the joists. Joists that run from one bearing point to another and stop are called simple or single span joists. Many times the structure is large enough that one simple span joist won't accommodate the entire structure and must then be supported by beams or bearing walls at the end of its span, and another joist must start on the same beam or bearing wall and carry the load to the next bearing point. All joists have a span capacity that can't be exceeded, or the joist will have too much deflection, causing the floor to be bouncy or could lead to possible failure. Many times joists are available in lengths that are much longer than the span capacity of that size joist. When this happens, the joist can be supported somewhere mid-span by a bearing wall or a beam below. When a joist is used this way, it's called a multiple or continuous span joist. Here, the span rates are larger on both sides than they are from point to point on a simple span joist, creating a stronger floor system. Next, we'll talk about beams. Beams are a component in a floor system that supports a joist, either from below, called a drop beam, or flush with the joist, called a flush beam. In most basement and crawl space systems, beams are dropped below the floor joist, and the floor joists bear on top of the beam. These are called drop beams. When headroom below the joist is a problem, such as a second floor system or a shorter basement area, the beams can be brought flush with the joist. The joists are then hung from the beam, typically with metal joist hangers that support them. If the beam must be deeper than the joist that they support, there are several ways that this can be accomplished. If headroom below allows, the beam top can be brought flush with the joist top and the balance of the beam left below the ceiling. If there is space or a wall above, the beam can be left higher and the joist can be hung flush from the bottom of the beam, and the balance of the beam can go up into the wall or space above. Either way, it's very important to know the difference between a drop beam and a flush beam in a floor system. If the beam is to be dropped into the walls below, it's going to need to be on the job site with the wall framing, as the walls below are framed. Now let's discuss joist and beam types. Joists and beams can be manufactured from many different types of material. In its most basic form, a floor joist is a dimensional piece of 2x lumber, typically 2x10s or 2x12. Anything less substantial than that usually does not have enough span capacity for most floor systems. Joists can also be manufactured from engineered lumber in the form of I-joists, LVL, LSL, or AFL materials. These materials are straighter, have more load-bearing capacity, and come in lengths up to 48 feet long, allowing multiple span systems with much stronger and straighter floors. Floor trusses are another form of floor joists. They are typically made out of 2x4 material and are engineered and manufactured to support a specific load for a specific structure. They're typically designed by a truss company who manufactures them and sends them out to the job site in exact lengths needed with a layout to show how they must be installed. We will cover the differences in all these materials in later episodes, but it's important to know that floor systems using these manufactured materials must be designed by an authorized designer representing the manufacturer of the products used or an engineer or architect who is qualified. Now let's discuss basic joist installation. Joists are most commonly run across the entire floor system at 16 inches on center. This is typically the maximum distance that joists can be spaced apart and still meet their span and deflection capacity. Since plywood, which is used for subfloor, is 48 inches wide by 96 inches long, 16 inches is a perfect spacing so that the subfloor can be nailed to the joist, and where one piece of subfloor ends, another can begin or break in the center of a joist. In some floor systems, joists can be 24 inches apart, such as truss systems and some I-joist systems. Typically, these systems have joists that are much wider than a typical 2x, which is 1.5 inches wide. Some floor systems need joist spacing that is less than 16 inches due to increased loads or longer spans of joists that must be maintained. Placing the joists closer together provides more support for the floor systems. In these systems, many times you'll see joists that are spaced 12 inches on center, 8 inches on center, or even doubled up at either 16, 12, or 8 inches on center, depending on the loads above and the spans of those joists and what they're made from. Now we'll talk about beams. Just like joists, beams can take many different forms and be made out of many different types of material. The most simple are made from multiple plies of dimensional lumber and nailed in such a fashion that they will support the load above. For instance, a joist system on a structure made of 2x12 material could have double, triple, or even quad 2x12 nailed together as beams around stairwells or openings or to support any point loads from above. Beams can also be made from engineered lumber. As with joists, these products are more stable, come in wider sizes and lengths up to 48 foot, and are much stronger. There are many types of products from many different manufacturers that beams can be made from. Parallel strand lumber or PSL, laminated veneer lumber or LVL, laminated strand lumber or LSL, glulams, and many more. These items will be covered in later sessions as well. The important thing to know about beams is that their purpose is to carry the loads of the floor they are supporting and transfer it to bearing points on either side of the beam. They can also be used to carry point loads that the joists can't carry. Beams must be engineered and sized properly. You should never use dimensional beams in an engineered floor system. The sizes are not compatible, and the different characteristics of the two products will create a poor performing floor system or could possibly lead to failure. Another component of floor systems is rim board. Rim board, or box, is typically the same depth as the joist that it is to be used in conjunction with. The purpose of rim board is to provide solid blocking on the ends of the structure and provide lateral support for the joists so that they cannot roll under load. Rim board also provides support for nailing around the perimeter of a floor system to install decks and porches, as well as to close off the floor system. In a floor system made from dimensional lumber, the same lumber as used for the joist is usually used for the rim. In a truss floor system, there's typically a truss called a ladder truss that runs parallel to the trusses in the floor system. It is called this because it looks like a ladder and has pins or stud every 16 or 24 inches on center to align with the walls below so that the point loads can be transferred to the foundation. In engineered lumber floor systems, the rim board is typically the same depth as the joist and made of LVL, LSL, or a variety of other products that are available depending on the manufacturer to provide support for both the connecting perpendicular joist to keep from rolling just like in a dimensional lumber floor system, as well as the joist parallel to the rim to provide support and to carry any point loads from above, as I-joists are typically not able to carry these point loads. Ledgers. Ledgers are similar to beams, but instead of carrying the loads from the floor system they are used in from point to point, they are fastened to a wall of the structure and transfer the floor load to the wall they are attached to. Since ledgers are usually attached to a wall with fasteners very close together, they typically only need to be of sufficient size to allow the joists they are supporting to attach with hangers. Subfloor is another component of wood frame floor systems. The subfloor is obviously the plywood that is nailed to the top of the joists that makes up the floor that you actually see and walk on. Plywood subfloor is typically 48 inches wide by 96 inches long and is tongue and groove on the 96-inch side, so it fits together and is supported between all of the joists. In addition, this tongue and groove is typically engineered to provide enough spacing so that as the subfloor expands and contracts, it doesn't buckle or warp. The subfloor is typically glued to the joist with subfloor adhesive. This is critical as it prevents movement of the subfloor and bridges all the small gaps between the joists and the subfloor to prevent any squeaking where nails or screws are placed. All wood connections in any floor system should be glued as well as fastened to prevent movement and squeaking. Bridging is another component of a floor system. Bridging is placed at spans of usually 8-foot increments to prevent joists from moving up and down and side to side on their own when loads are placed on the floor and they lock the entire floor system together. Bridging can be in the form of dimensional lumber that is the same thickness as the dimensional lumber of the joists and runs between them. In an engineered lumber floor system, it can be the same material as the floor system. This is called solid bridging. Bridging can also be made of metal strapping or wood, which is typically nailed to the top of one joist and brought down at an angle and nailed to the bottom of the next joist. Another piece of strapping is brought to the top of the other joist and brought down at an angle and nailed to the bottom of the first joist, creating an X. This is used in dimensional lumber systems and locks the joists adjacent to each other so they can't move. It's important to run this type of bridging in the right fashion, or the two pieces of bridging will rub against each other, creating more potential for squeaks. Metal bridging is usually not used in either truss floor system or an engineered lumber floor system. These floors are designed to work without any bridging. Bridging installed without the consent of the manufacturer could void the warranty on those products and create squeaks. Connectors are another important component of most floor systems. Connectors usually come in the form of joist or beam hangers. Joist hangers are metal connectors used to connect joists to ledgers and beams. Connectors can take many forms. They can be flush mount, top mount, skewable, slopable, or all of the above. Hangers are available for just about any application. Many times, beams must support other beams. In this case, a hanger of sufficient capacity must be installed either face or top mounted of one beam, and the other beam must be slid into it. These hangers should always be engineered and specified prior to installation by a qualified engineer or manufacturer's rep. The last component we will cover in this session are posts. While posts are not usually part of the floor system itself, they are important to carry the load from the floor system that they are supporting down to the foundation. In a first floor, in a typical crawl space or basement, a post might be in the form of a steel lolly column that sits on a concrete footing in the middle of the structure and supports a beam that is supporting the joist above. Typically, posts are placed on either side of the beam they must support as well as spaced intermediately. Posts must stack on top of each other or have bearing walls or beams below them that carry the load all the way to the foundation. Posts, like beams they support, can be made from dimensional lumber that is solid or plied, or can be made from engineered lumber. We'll talk more about posts in our wall systems segment. While this certainly doesn't cover everything about every floor system, it should give you the basics to be able to discuss them intelligently. I encourage everyone to comment with any questions or additional information that you would like to provide. Thank you.
Thanks for watching, and feel free to reach out with any questions or comments you may have. Stay tuned for our next episode on basic wall systems.